Addressing electrical safety in temporary power distribution is crucial. The temporary electric industry demands careful attention to safety because of inherent risks. Here are common approaches for mitigating risks. Firstly, regulatory compliance is paramount. Adhere to the California Building Code and National Electrical Code requirements for temporary electrical installations. Obtain necessary permits and inspections from local authorities. Secondly, contractor selection is vital. Partner with licensed and experienced electrical contractors who specialize in temporary power distribution. Verify their insurance bonding and safety records. The electrical design and installation necessitate ensuring that temporary electrical installations meet the load requirements of the equipment being used. Use approved materials and components that comply with industry standards. Install properly sized conductors in accordance with National Electrical Code guidelines. Provide proper grounding and bonding systems. Safety checks and inspections are essential. Conduct thorough inspections before energizing temporary wiring. Use non-contact voltage detectors to verify that circuits are de-energized when not in use. Inspect tools, cords, and equipment for damage or defects. Training and education are critical. Provide training to personnel involved in the installation and operation of temporary electrical systems. Familiarize them with potential hazards, safety protocols, and emergency procedures. Risk management should be implemented. Implement a risk assessment process to identify potential hazards associated with the temporary electrical installation. Develop mitigation strategies to minimize these risks. Establish a safety plan and communicate it to all project stakeholders. Equipment management is necessary. Use and maintain temporary electrical equipment in good working order. Regularly inspect cords, plugs, and other components for wear or damage. Store equipment in a dry and protected environment. Communication and coordination are also needed. Establish clear lines of communication between contractors, inspectors, and project managers. Coordinate the installation and operation of temporary electrical systems to ensure safety and compliance. From an inspector's perspective, it is crucial to thoroughly review electrical plans and specifications to identify potential safety concerns. Conduct rigorous inspections to verify compliance with codes and standards. Issue violation reports for any hazardous conditions or non-compliance. Provide guidance and support to contractors to ensure safe electrical installations. By implementing these practices, industry professionals and inspectors can work together to mitigate risks and improve the safety of temporary electrical installations. Important considerations include regulatory compliance. Understanding and adhering to the California Building Code and the National Electrical Code is foundational. This ensures that all installations meet the minimum safety standards. Navigating the permit process and scheduling inspections with local authorities are critical steps to validate the installation's adherence to these codes. Proper permitting not only ensures compliance but also provides a documented record of safety oversight. When choosing electrical contractors, prioritize those with specific experience in temporary power distribution. Scrutinize their insurance coverage to ensure adequate protection against potential liabilities. Bonding provides an additional layer of financial security. Reviewing their safety records offers insights into their commitment to safety practices and their history of incident prevention. For electrical design and installation, ensure that temporary installations are designed to handle the intended load. Using approved and industry standard materials is a non-negotiable aspect of safe installations. Accurate conductor sizing, guided by National Electrical Code tables like 310.15, is vital to prevent overheating and potential fires. Proper grounding and bonding are essential for minimizing the risk of electrical shock. Safety inspections are another key area. Perform detailed inspections before activating any temporary wiring. Non-contact voltage detectors are indispensable tools for verifying that circuits are properly energized. Regularly inspecting tools, cords, and equipment helps identify and remove any damaged or defective items. Regular training and educational programs are a must. Provide comprehensive training to all personnel involved in setting up and using temporary electrical systems. This training should cover hazard identification, safety protocols, and emergency response procedures. Personnel should be fully aware of potential hazards such as exposed wiring, overloaded circuits, and improper grounding. Emergency procedures, including lockout, tagout, and first aid, should be clearly communicated and practiced. Always conduct a risk assessment. A systematic risk assessment should be conducted to identify potential hazards specific to each installation. Develop specific mitigation strategies for each identified risk, such as using ground fault circuit interrupters in wet locations or providing physical barriers around exposed conductors. A written safety plan should be created and communicated to everyone involved in the project. The plan should outline safety procedures, emergency contacts, and responsibilities. Proper equipment management is crucial. Implement a program for regular inspection and maintenance of temporary electrical equipment. Damaged or worn cords, plugs, and connectors should be immediately replaced. Store equipment in a dry, secure environment to prevent damage and deterioration. Maintaining detailed records of equipment inspections and maintenance can help track the condition of equipment and identify potential problems before they lead to incidents. Effective communication and coordination are also important. Establish clear communication channels between contractors, inspectors, and project managers. This ensures that everyone is aware of the installation's schedule, potential hazards, and safety requirements. Coordinate the installation and operation of temporary electrical systems carefully, particularly in complex projects. Scheduling regular meetings and walkthroughs can help identify and address potential safety issues proactively. From an inspector's point of view, plan review is important. Thoroughly review electrical plans and specifications to identify potential safety concerns before installation begins. This review should verify compliance with all applicable codes and standards, including conductor sizing, grounding, and overcurrent protection. Detailed inspections should be carried out during and after installation to verify compliance with the approved plans and specifications. This includes checking the quality of workmanship, the condition of materials, and the proper installation of safety devices. Issue violation reports. Any hazardous conditions or non-compliance issues should be documented in a violation report. The report should clearly describe the violation, its location, and the required corrective actions. Follow-up inspections should be conducted to ensure that all violations have been properly addressed. Guidance and support should be provided to contractors to help them understand and comply with safety regulations. This includes offering technical advice, providing educational materials, and conducting training sessions. Inspectors should act as resources for contractors, helping them to improve their safety practices and prevent future violations. The NEC, or National Electrical Code, provides comprehensive guidelines for electrical installations. Article 590 specifically addresses temporary installations, covering aspects such as wiring methods, overcurrent protection, and grounding. Understanding and adhering to Article 590 is crucial for ensuring the safety of temporary electrical systems. For instance, Section 590.4 addresses the acceptable wiring methods for temporary installations, emphasizing the use of listed flexible cords and cables. Section 590.6 outlines the requirements for grounding, ensuring that all non-current carrying metal parts are properly grounded to minimize the risk of electrical shock. Section 590.8 focuses on overcurrent protection, requiring the use of fuses or circuit breakers to protect circuits from overload. Ground fault circuit interrupters, or GFCIs, are essential safety devices that protect against electrical shock. GFCIs should be used in all temporary electrical installations, particularly in wet or damp locations. These devices quickly detect any imbalance in current flow, indicating a ground fault, and immediately shut off the power. This can prevent serious injury or death from electrical shock. Portable GFCIs are available for easy use with temporary power cords and equipment. Regular testing of GFCIs is important to ensure they are functioning properly. Lockout-tagout procedures are designed to prevent accidental energization of electrical equipment during maintenance or repair. Before working on any electrical equipment, the power should be disconnected and locked out using a padlock. A tag should be attached to the lockout device, indicating that the equipment is out of service and should not be energized. Only the person who placed the lock and tag should remove them. Following lockout-tagout procedures is critical for preventing electrical accidents. Proper grounding and bonding techniques are vital for preventing electrical shock and fire hazards. Grounding provides a path for fault current to flow back to the source, tripping the circuit breaker and de-energizing the circuit. Bonding connects all non-current carrying metal parts together, creating a low impedance path for fault current. This ensures that all metal parts are at the same potential, minimizing the risk of electrical shock. The grounding electrode system should be properly installed and maintained to ensure its effectiveness. Regular inspections of grounding and bonding connections are important to identify and correct any loose or corroded connections. Additionally, Article 305 of the NEC provides further guidance on temporary electrical power, covering topics such as branch circuits, receptacles, and lighting. Temporary wiring should be supported and protected from physical damage. Cables should be run in a way that minimizes the risk of tripping or snagging. Cords should not be run through doorways or windows where they could be damaged. Proper support and protection of temporary wiring help prevent damage and reduce the risk of electrical hazards. Overloaded circuits are a common cause of electrical fires. Avoid overloading circuits by using properly sized conductors and overcurrent protection devices. Do not plug too many devices into a single circuit. Use a circuit analyzer to measure the load on each circuit and ensure that it is within the safe limit. If a circuit is overloaded, reduce the load or add additional circuits. Regular inspections of temporary electrical installations are essential for identifying potential hazards and ensuring compliance with safety regulations. Inspections should be conducted by qualified personnel who are knowledgeable about electrical codes and standards. The inspection checklist should include items such as wiring methods, grounding, overcurrent protection, GFCIs, and lockout-tagout procedures. Any identified deficiencies should be corrected promptly. Using the correct type of code for the application is essential for safety. Extension code should be rated for the intended use and environment. Outdoor cords should be weather resistant and suitable for wet locations. Heavy-duty cords should be used for high current applications. Never use damaged or frayed cords, as they can pose a serious electrical hazard. Regularly inspect cords for damage and replace them as needed. Effective communication is critical for ensuring the safety of temporary electrical installations. Establish clear communication channels between all parties involved, including contractors, supervisors, and workers. Hold regular safety meetings to discuss potential hazards and safety procedures. Post warning signs in areas where electrical hazards exist. Encourage workers to report any unsafe conditions or practices. By fostering a culture of open communication, you can create a safer work environment. A well-documented safety plan is essential for managing risks associated with temporary electrical installations. The plan should outline specific safety procedures, responsibilities, and emergency contacts. It should also include a hazard assessment, identifying potential hazards and outlining mitigation strategies. The safety plan should be reviewed and updated regularly to reflect changing conditions and new information. The safety plan should be readily available to all personnel involved in the project. When working with temporary electrical systems, it is important to be aware of potential arc flash hazards. Arc flash is a dangerous electrical explosion that can occur when there is a fault in an electrical circuit. Arc flash can cause severe burns, blindness, and even death. To protect against arc flash hazards, wear appropriate personal protective equipment, such as arc-rated clothing, gloves, and face shields. Follow safe work practices, such as maintaining a safe distance from energized equipment and using insulated tools. Conduct an arc flash hazard analysis to determine the potential arc flash hazard level and select appropriate protective measures. By taking these precautions, you can minimize the risk of arc flash injuries. It is important to stay informed about the latest electrical safety regulations and best practices. Attend training sessions, read industry publications, and participate in professional organizations. By continuously improving your knowledge and skills, you can help ensure the safety of temporary electrical installations. Proper planning and execution are paramount.